get you guys started, what's happening between 0 to A? If you're to describe this situation.
If you're gonna do it, I'm not.
Sorry? What's going on between 0 and A?
4 minutes.
In
4
4
minutes.
minutes, 4.5.
Yeah, go for it.
Water filled up to 27, or yeah, 27.
Increase to what? Sorry, 20.
27 liters.
Okay. Again, that is bare bones describing what's going on. If you wanted to put a story to it, totally up to you. If you want to go as minimal as that, that's okay too, alright? Between A and B, what's going on?
It stay the same.
A and B stayed the same. So
Kinda
between,
like
what is that? Between
4.5 to 7.5.
no change. Okay? Between 7.5 to almost 8, we'll just call it 8 to make it easy. What happens?
The water quickly increases
To approximately what?
32.
Okay, what happens between 8 to 17?
It stays the same.
No change. And then from 17 to, let's say 18,
Quickly decreases.
goes down to, I guess, what did we use before? 20?
8 to 19. It's under.
It's 19, 20 at this point. You get my point. The big thing I'm worried about is your ability to see the increase and decrease or no change. Okay, and then no change. The next one, 18. What was that?
Well, that was fine.
No change. And then finally, this is like.
Is it shaking?
Okay, good. I'm not the only one who sees that. There's an earthquake.
Woo!
Probably just a pixel.
Yeah.
No.
Might be the whole. I think the whole building. The whole school
Bet you
is
could
having
afford
an earthquake. Okay, the last one from 19 to 24. Okay, it decreases to 0. So, for those that got this point and had the idea of those, that's your bare bones. The other thing, other skill that you can have is actually getting a little bit creative and figuring out a scenario in which this could be happening. What's
extra marks for that?
It's not so much extra marks. There will be an outcome though that I'll give you a question and it'll just say, describe a situation that could happen from this graph. And we'll actually do an example of that here shortly. Sorry?
Shower.
Yeah, but guys get into the. Johnny's having a little bath. He's having a bubble bath. Okay? First time he fills it up to a certain point, stops, he tests the water. If it's good, then he fills it up to the top, has his bath, unloads. For some reason, he magically stops it again for
Or it
30
could
seconds.
be John, he filled it up, and then he sat in it, so the water went up.
Mhm.
So then he stepped out, so it went down the same thing, then he drained
I
it.
was thinking about this the other day, and the only reason why I always worry about this one. I wonder why I was thinking of this only math question. No, I was teaching it the other day.
I was on there towards.
Oh, I was wondering about this one. The only other thing I could think of is if your most bathtubs look like this, right?
Yeah.
Maybe if this bathtub did something like this.
It's like one of those fancy ones, like the Bojangles and stuff.
Oh, there's going.
Yeah, if it did like something like that.
I'll take you back.
Yeah, like where it's a sit down, right?
Yeah.
But that would be an example. Maybe something like that. I don't know.
It's not-
But again, whatever
That's the first one you.
whatever story, whatever creativity you've got that you want to give to the story, as long as it makes sense, I'm good with it, okay? But you will be asked at some point to be given a graph that I want you to describe. It won't have numbers, it'll just say, here's the trend, okay? Explain to me what's going on, alright? I believe actually that's our next example. Yep, it is. Okay, so you've got two examples here. I want you to explain to me, or give me two creative examples as to what could be happening with these two graphs. One example you've got, the only parameters you're given, is that your y-axis has to be distance from home, over time. The other one is your total distance over time.
Are those
Okay.
two connected?
These two graphs, no, you can make two different stories from this. If you wanted to connect them, that's okay, but you can make two different stories describing both scenarios. So, on your desk, you should have two stories that you need to have filled out, okay?
It took him 30 minutes.
We have to make up the time.
Time is not the issue, time is not the need. What I would talk about usually, I'm getting rid of the numbers because I want you to be able to describe what's happening in your
I
works.
need to book it.
How do you do that?
What's up?
Unacceptable.
Up to you, go for it. See what happens.
Distance from here to my house is 1,000.
I should have went with exactly.
I didn't know this.
Very good response. No, unacceptable, not happening.
Need to put
I
your
don't
foot down.
follow it.
Teach you.
I can't even read.
Well,
Here we go. The table was.
Poop. Was walking.
no, so the big thing here is the numbers aren't really needed, it's the describe what's happening, I'm going up again. You can use describing words to explain if it's at this pace, right? Don't say 30, but say like, for the first one, I would say, if I'm going distance from home, from my example, I would be like, Colin walked from here to here, then he ran fairly quickly, then he slowed down almost to a stop, walked again, and then ran home.
Do we have to do
The
that?
describing words being walk and run, okay? Changing my speeds. My speed here would be much different than this one.
Well, you'll understand when you
That's fine. I'm just giving you one example. So just being able to distinguish between different angles of your line segments. Okay?
Do we have to do the time?
No. Time is implied whenever you are talking about the situations. Let's go. Abby, that's not even written anything. You've got some graphs.
Are we supposed to create art?
Yes, make your own.
Okay.
Make your own scenario. New York Rangers wins and losses. You son of a gun. Alright, you keep going. I want to see how this goes up. Ooh! Yeah, the graph doesn't do a good depiction.
They went top.
So, did you read
I mean,
this?
we beat the Habs at least once, right?
This year? I don't know about that actually.
Can I read it?
Yeah.
Andre. Andre.
Even with scribbles and
Oh,
There you met a friend.
catch loose balls, I don't know.
He's the guy, he's the worst player.
All that build up and nah.
Does it work though?
Yep, try another one.
Okay. Andre's awesome.
He must be a call sheet.
Hold on 1 second.
Once again, the big thing is being able to describe the scenarios that are happening.
Okay. What do I have to do for the second one?
Forward.
Great day. That's good.
oh, let's go down. Oh, this thing.
problems had.
They just started, just went on a spiral.
Logan was 4 over the
When? What year was that?
I'll go with this one.
Oh, you're talking about when we play the Rangers.
The Habs gonna make the playoffs first. As it stands right now, there is no Canadian teams making the playoffs, which is crazy.
We're saving you need Price in the worst way.
We're saving him for an epic comeback. Everybody thought Edmonton was going to make it because of McDavid, even though they said like 3 months he's been gone for like 4 now.
Him and Talbot when they traded for Talbot, they're like, oh, we're done. This is there's our goalie. He's here. Yeah.
I went to Edmonton. Okay, when I was like a couple months back, but I wanted them to Talbot got like the stupid goals for all he had to do was post it more and it would make it going into like then this guy would walk and bounce, big shot over there, broke like the shot over the guy started going,
Heather, say hi.
Fuck.
Mr. Dillon way downstairs and doing
Mr. Gillian.
He's having a bad day. His anger quickly increases. He got this girl. Then he saw Tori. Then she left for a second. So his anger slowly increased. After he slowly got angry. To quit.
It works.
That's pretty ruthless, though. That's okay. He was. What's this one? He was driving. That's okay. On a highway. So you need stop this car that slowly moving. Good. Is there anybody else that wants to share their story for the entire class?
My favorite class is there.
Is that because of me or what?
Other than the Ranger one. Devin made a funny joke. Okay, so which is good because you can really make those. You can make those graphs up to you. For the assessment or for your task that I got on Google Classroom, I believe I give you something similar where I just say, here's your scenario, here's your parameters, try to describe it as best as possible, okay? So, just looking around, I saw most, if not all of you, had some form of a write-up, which was great, okay? So if we keep going, I want you to think about these two examples here. Focusing again on what your parameters are. Neither one of these graphs can work. You don't need to write it down, but brainstorm with either a group or with someone nearby about why those two graphs cannot occur. Okay.
What comes the last one?
Aww. It's gonna drain the lid just
rip,
too long.
rip.
Yeah, it did. Yes, it did. Look at it. See? It did.
Look at the total distance for the second one. I did the same thing. The first part, I was like, I didn't understand why it couldn't work.
Second first one goes like backwards.
First, what's wrong with the first graph?
It goes back.
You're going upside.
We're going back in time. Can we do that yet? What's that? We turn back the clock. So that's the issue, is that we cannot go back in time. So that graph could not be possible. Okay? The second one, I saw two things. Is there anybody see anything wrong with the second graph?
Is it where it starts?
Nope. Where it starts, it's fine.
Why can't it be like?
Oh, it goes down the middle there?
It's something to do with this part here. What's going on here?
What if it's total distance, then you might be walking backwards, going backtracking?
But if I'm still going total distance, I can still backtrack. If I'm adding up my distance, doesn't matter if I go up, down, left, right. It's still steps, right? That's where it would be. You're right. If I wasn't doing total distance, if I was doing distance from home, if home is this wall, and I walk here, yes, it's going to increase. But if I backtrack, yes, it would go down. But because it's total distance, if it took me 10 steps to go front, 3 steps back, I still took 13 steps. Okay? The second thing that I noticed was this point here. Does time stand still?
Nope.
No. What? So unless this person was abducted, he just magically stopped and time stood still.
That's
They
where
might
it
have
was.
reached their destination.
Potentially, that could be the end of the graph. The way I look at it too is maybe if they reach their destination and they're still this far away, you should still have an arrow. Anytime in graphs that we want to represent something that goes on and on and on, we represent it with an arrow. Okay? When we start doing our line graphs, my expectation will be that when we start doing linear graphs with linear equations, we will start using graphs, and we'll always, when we draw it, we'll always have an arrow at the end to represent that it goes on at a constant rate. Okay? Questions on that?
Repeat that.
Nope, we're almost done. Okay? Here I want you got 3 examples. Actually 2. You can choose which graph to use, whether you use total distance or distance from home. But I've got 2 scenarios that I want you to draw the graph for. Okay? Draw a graph that represents each one of those scenarios, right? On your desk.
I'm just gonna do total
sure what
distance.
I don't know if I want to see it.
Well, carry price, save percentage. Doing well. No shots fired. Too good. Doing good. Being too good. Doing fantastic again. Almost shut out. Probably gets
Funny. Funny.
You can create
Do we have to write down times and stuff, or can we just write it down?
Just do the same thing. You're just drawing a representation of what the scenario is.
Wait, can we go back? Because she said she walked to school and then went back home.
Try to see how you draw it. See what you come up with.
The only way you go back.
Read the sides there, right? See, one is distance from home, one's total distance. Okay? Choose one of the 2. You don't have to do both. You can pick total distance or distance from home. Okay, guys, let's go.
We have to do it on the desk.
Yes. Where else are you gonna do it? Do you have your pen? Do you have paper and pen? Oh. It's a good start. Yep.
Do you want us to have another day?
Wait, can you just like do that? That said, she walked to school and then walked back.
No, we're still going over time. That would be if we were back. That would be going back in time.
Message.
So Dylan, let's say the house is right here.
Okay.
So she walks to school, I just draw this line, or?
It's good, but what happens with the total distance? When she walks to school and then walks home, where does she go there? So yes, this is school. Walks to school. Great. What's the next one? Right home. If you're doing total distance, where should you go next? No, because you can't go back.
She goes forward.
Do you need me to do the first example for you?
Sure.
Okay, if I choose distance from home, I'm going to try this one first. Okay, again, we've been talking about breaking it up into line sections, right? So take each scenario. This would be my first line. This would be my second line, third line, and then fourth line. So I should have at least 4 lines. Okay? If I'm doing distance from home, if I'm starting at home and school is here, okay, I walk to school. So I'm going to make it like that. Walk to school. Typically, when school starts, you're at 9 o'clock. You don't get lunch till, let's say, 12 o'clock. So what's going on between 9 and 12 o'clock? I'm still at school, correct?
Might be shy.
What's that?
Like then
I might have moved around, but let's just say for all intents and purposes, I'm in the school, that's the distance, okay? At lunchtime, I run home. Is my line going to be steeper or longer than this one?
Steeper.
It's going to go pretty much, it's not completely straight down, but it's pretty close, okay?
Wait, the home is like the line. basically?
Yeah, so my home would be this axis here, right? Because my distance from home is 0. I'm at home, so it must be 0. I have a quick lunch, and I run right back to school. I stay at school till 3, and then I walk home.
Oh, okay.
Is that the only graph? Not necessarily. You might not have to account for the time in between lunch and school. However, the big thing I want you to take away is the fact that she's walking and then she's running. Running, walking. You have to represent those different speeds based on the slope that you're using, okay? So having said that, I want you to try this next one about Bill driving to Edmonton from Grand Prairie, starts with a full tank and fills up in Whitecourt.
Isn't it from here to Whitecourt?
2 hours.
Yeah, it's about 2 hours.
You started with a full tank. Awesome.
So check out, make sure you look at your graph that they're telling you, the parameters here. Your y-axis is gas remaining, so how much you're starting with.
Wait, shouldn't the starting point would be at the top of the y-axis?
Yes, because you got a full tank.
So it's one.
This is all it does is just go down.
If he stops for gas, Zach, is he not going to fill up?
So he's like,
Wait,
it's supposed to be going straight sideways. So if he stops for gas.
Yeah, he stops for gas. What's happening to
And
the
then-
gas as he stops at Whitecourt?
it goes to Edmonton.
Oh, it should go up.
It should go back up, right?
Oh, okay.
And this is a full tank right here. He's filling up, so it should.
No,
So
it
it should
should
still
go
go
down.
sideways.
No, it should. It might not be. Well, think about it.
Oh,
Road.
to Edmonton to
Stop for a
Grand
little bit,
Prairie.
go back up.
Yeah, and then think about so you
Oh, so
gradually
it's
lost
like
the gas
from
here. If he
Edmonton
stops at
to-
Whitecourt,
Grand.
We drove to Edmonton from Grand Prairie.
is it gonna go? Is it gonna be quicker for him to fill up than it is for him to drive on get the gas? You know what I mean?
Yeah.
Yeah. So
So he
this
started
line
from-
is gonna go back up, but it's gonna be the same pace as this one.
It
Oh, it would go
just
down
says
again.
you started with a full tank
In Grand Prairie.
No.
and then had to fill up.
If it took him 2 hours,
It's not gonna take him 2 hours, right, well, take him like.
So this, it would be almost, yeah, it would almost be straight up.
Would it go down again, Dylan?
Because he
That's a
goes
good
to
one.
Edmonton.
Yeah, and then he's driving back to Edmonton. He's got another, let's say it's 2 hours from Whitecourt. It's 2 and a bit, I believe.
It's 2 hours from Whitecourt to.
Yeah, I think I've done it. I think the quickest I've done here to Edmonton was 4 and a
What's the
half.
quiz? What's the
4 and a half, and
quickest-
I'm downtown. I'm right down
What's
by
your
it.
highest speed whenever you drive in a highway? What's
I try to stay the speed.
really?
I try to. I've got.
What's your highest?
What's my highest? Are you talking about me when I was a 17-year-old with my license, or are you
Sure.
talking about currently?
Sure.
We won't go into what I was like when I was a teenager because I'll be promoting bad habits to you guys.
What is
Okay.
it? Tell us.
No, let's keep going.
What is it?
Oh, can we be done?
The big curveball here.
Come on.
The big curveball with this type of a graph. When I'm starting from Grand Prairie, my gas tank is full. Do I start my graph here?
No.
No, I start at the top because this represents a full tank of gas. If it takes me 2 hours to go to Whitecourt, I'm going to gradually lose my gas all the way to Whitecourt. Let's say I made it to Whitecourt. I'm filling up my tank. So this is the question I asked Zach. I said, it took you 2 hours to lose this much gas.
It's not.
Is it going to take you 2 hours to fill up your tank? No, it's going to take what, like 10, 15 minutes tops?
Probably 5.
So compared to this is 2 hours, you're almost going to be straight up to fill your tank back up again. And then let's say it's another 2 hours to get you to Edmonton. Okay?
I don't think it's gonna like. Oh, if he goes full tank again.
Again, sorry?
Is he gonna go full tank again?
Yeah, if he fills it up, I would assume if you're stopping in Whitecourt, you're not going to go, I'm just going to put $20 into it. Just hope it works. You're filling up. If you're stopping to fill your tank up. Okay? So again, it's talking about the gradual slope about each of these pieces, right? You're going from here to here at a slower rate than you would have filling up your tank. Okay? Let's leave this last example because I think I've just beaten a dead horse here, right? You guys and girls understand that? Make sense?
Yeah, so I'm not doing it.
What? There's still 10 minutes left of class. I got one little piece for you, right? This is a good start, alright? This is understanding and analyzing graphs and understanding what's going on with each graph, okay? The last thing we're going to do is we're going to talk about different ways to represent data. So we understand what's going on with graphs. Now we need to show different ways to build them, okay? Ordered here are 6 different ways you can represent data, and 6 different ways that you can use that representation to graph your data, okay? We've got a table of values. We're going to rhyme off these ones. If you don't know what it is, I will give you an example. Does everybody know what a table of values is, or a T-chart? Everybody remembers a T-chart? Yes, no? T-chart is this. You've got X on one side, Y on the other. Ordered pairs. Ordered pairs is a way to represent a data point. So if I have a point on a graph, I think I have a graph down here. No, I don't. Okay? An ordered pair, if I say that there's a point on the graph that's at x equals 1, y equals 2, x equals 1, y equals 2, I write it as an ordered pair, 1, 2 in brackets. Has anyone seen this before? Has everyone seen this before? Yeah. Awesome. Graphing we all know because we've just been doing it already. An arrow diagram is the same as a T-chart, but if I have 1 and 2 for x and y, instead of having a line through them, I literally just draw an arrow to the ordered pair that it matches up with. An equation, we're going to start talking about the equation for linear functions. Y is equal to mx plus b. M equals your slope. B equals something called the y-intercept. We'll talk about what that is in one of the examples. Okay? And then words, we're explaining. Hello? Hey. Yeah, I can. I'm going to go down shortly. So words are explaining, you use to explain basically what we've been doing already. Here's a graph, explain what's happening, okay? Whoa. Each relation, there are 2 parts. Domain, we talked about this. Domain always deals with the x-axis. Range always deals with the y-axis, okay? Again, it's talking about your minimum and maximum values within that graph. Where the domain range is given must be in that. We'll talk about that in a second, I believe. Okay, what I want you to do while I run down is I want you to take this information and I want you to try to graph this line. Okay? If the bell rings, I shouldn't be too long with Miss Corcoran, but nope, I want you to do it on your desk.